A substantial share of projects within financial market infrastructures involve software development activities based on Agile methodologies. In this video, we will explore the software methods that support large-scale transformation initiatives and business-as-usual operations in high-availability environments. Hi, my name is Dmitry, and I'm a part of the Exactpro's research team. I'm coming to you from Georgia, the home of Exactpro's biggest delivery center. Georgia has ranked 7th among 190 states in the World Bank Doing Business 2020 rankings. Information and communication technology has always been one of the key emphasis areas for Georgia, with much attention being paid to education, innovation, and expanding the IT infrastructure. The first Exactpro office opened in Tbilisi in the fall of 2018. It expanded fast, and now we have 2 co-located offices, with a third one opening this summer. Today, the branch employs almost 300 quality assurance engineers and developers, both in senior and junior positions, as well as software engineers and test. A new job description for specialists working with our next-generation test automation framework, TH2. As a leader in software testing and related software development, Exactpro has successfully focused on promoting professional excellence in Georgia, building and nurturing a local QA community, creating JOSTQB, a Georgian representation for International Software Testing Qualifications Board, establishing links with universities, and actively showing support for IT students from across the country who study there. Internationally, Exactpro works with exchanges and clearinghouses, the most mission-critical institutions in financial services. We deliver our services to clients in more than 20 countries on all continents, covering the most scalable, latency-sensitive, and reliability-sensitive systems across the globe in our industry. We have been in business since 2009 and employ over 750 specialists. Exactpro is headquartered in the United Kingdom. We have our delivery centers in the US, Georgia, Sri Lanka, and Lithuania, with representative offices in Armenia, Italy, United Arab Emirates, Canada, and Australia on the way. Our narrow focus is software testing. But what is software testing? Let me answer this question from our Tbilisi studio. We can Google it. These are the first links that Google Scholar gives us. The top links contain words like art, craft, research, etc. In software testing, a craftsman approach is presented as a continuum from art to craft, to science, to engineering. Some go even further and extend it to data journalism or claim it to be magic. Lots of vendors insist that their software testing product is turning software testing into engineering. And what is the difference between scientific inquiry and engineering? These two processes go hand in hand, expanding human capabilities. It's not possible to achieve great engineering without a solid scientific foundation. And cutting-edge science requires more advanced instruments and tools produced by engineers. But there is a fundamental difference there. While engineering is turning an idea into a useful product, the scientific inquiry is trying to understand a physical object and build its abstract model. Again, what is software testing? Software testing is exploring software with an intent of finding bugs. Software testing is an empirical technical investigation conducted to provide stakeholders with information about the quality of the system under test. Software testing is an information service dedicated to finding things that decrease the value of a product. It shows the presence of bugs, not their absence. So how do we measure the value of testing? There are 4 main principles of how you measure the quality of data or the quality of information service. They are accuracy, relevance, interpretability, and accessibility. The last one is accessibility. Information, if not accessible, is of no value to others. Think about a crypto wallet without a password. The value is there, but you are not able to extract it. At the same time, if information is accessible, but others are not able to interpret it, then they are not able to use it. Software testing is a social process. Now let's look at the first 2 data quality characteristics, accuracy and relevance. Both are of great importance from a software testing perspective. Accuracy stands for our ability to detect important defects, and relevance stands for our ability to provide relevant information to detect defects as early as possible. There are several measurements of accuracy known from machine learning classifiers. Accuracy, precision, recall, also known as sensitivity, and F1 score. Some companies use the percentage of rejected defects as one of the major KPIs, thus prioritizing precision. In high-stakes environments, sensitivity is way more important than precision or accuracy. There's a film about software testing in high-stakes environment. It is called Pentagon Wars. And there's also a song about the software testing in any environment. It is called Ironic. If you read the definition of what ironic is, you will see that it's the definition of what software testing is about. An incongruity between the actual and the expected. Relevance of information varies depending on the context. If you refer to the song, it is a black fly in your Chardonnay versus a death row pardon 2 minutes too late. In different industries and various contexts, the relevance of information may differ. And the relevance is most important for the Agile context. Let's talk more about Agile. In Exactpro, we rely on peer-reviewed paper that defines agility as responsiveness to change. Agility is not following particular rituals. It's whether a person, a team, a company, an industry, or a country can be responsive to change. And we know that currently in the world, the only thing that is constant is change. And another constant thing is the challenges that we face trying to respond to change. There are multiple definitions of Agile testing. One of them states that it is a software testing practice that follows the principles of Agile software development. But, as already mentioned, software development and software testing are two different processes. This definition would be similar to Agile cooking is a cooking practice that follows the principles of Agile hunting. In the ISTQB glossary, we have a better definition that defines Agile testing as any testing performed within Agile project and Agile development practices. The seminal book on Agile testing by Gregory and Crispin contains several references, but we were not able to extract the precise definition of what Agile testing is. On the other hand, these books contain useful and frequently referred to concepts of Agile testing quadrants. You can now see them on your screen. In Quadrant 1, there are things like unit tests. In Quadrant 2, we have BDD and specification by example. In Quadrant 3, we have exploratory testing. And in Quadrant 4, we have things related to the technical aspects. If we think about unit tests, we will realize that it is the definition of software. Software is a collection of instructions and data that tell a computer how to work. The computer's hardware is able to execute the software. Each instruction causes the computer to carry out an operation, moving data, carrying out a computation, altering the control flow of instructions, or manipulating hardware. So if you look at this definition and then comparing it to what unit tests are, you will see that they are software. One more time, writing unit tests is not performing software testing. Writing unit tests is developing software because unit tests are software. Now to the second quadrant. BDD is also a set of instructions. You collaboratively define executable specifications and it allows you to run it. What exactly are you running when you launch BDD tests? You're running software that performs instructions and modifies data. On the left, we have software. And the processes in Quadrant 1 and Quadrant 2 are called building software or software development. On the other hand, the processes on the right is testing software. There's a very clearly defined boundary between these two activities that have an anti-parallel flow of information. Build software to test software. In order to run testing in the Agile context at scale, it is necessary to have tools that will cover the quadrants on the right, Quadrant 3 and Quadrant 4, and help with software testing within large-scale Agile implementations. Software testing relevance is crucial in an Agile context. So how do we define whether our software testing activity is relevant to the overall process? It is relevant when the information that it provides is relevant. For example, if we find more defects than the development team can process, it means that a number of them might have a decreased value. Or if a software development team is capable of building more software than we can study, research, and identify defects in, it once again shows that our information is less relevant to the rest of the team because we provide the information later than necessary. When you test within large-scale Agile limitations, it is necessary to make sure that both processes can run in parallel at approximately the same pace. It requires engineering both in building software and in testing software. Any large-scale successful implementation that we have seen so far has the same features. And there's a very good book that describes large-scale Agile development transformation within Hewlett-Packard. It is considered to be a huge success by reducing overall development costs, increasing the amount of innovation, and achieving the dream goals of every large-scale agile transformation. Among other things that they did is building a large number of test environments where information is obtained at any stage. There are some checks that are executed on commit, there are some checks that are executed in a large environment, and there are some large-scale regression libraries that constantly run. One of the things that you need for optimizing feedback loops in complex large-scale systems is to throw hardware at it, because you need to have test environments where you'll be able to run small unit testing, and you will also need to have large environments when you are able to cover the system as a whole. And also, if the next version is available, you have two options. You can stop executing large-scale automated checks and start against a new version, or you can proceed and take the new version as well and execute it in some other environment. By running more tests in parallel, we can obtain more information faster. The same case study presents a success achieved in development effort relocation. Overall development costs were decreased by 40% and the effort spent on innovation increased 8 times. The diagram on the screen shows effort distribution between various activities before and after the transformation. You can see that on the right side we have 77% instead of 100. The remaining 23% are spent on development and improving automated checks. If you drill down into these 23%, 3 went to test tool development, 10 went to scripting checks, and 10 went into the failure triage process. You can sum it up. 5 from the most testing is now automated and 10 from failure triage. And compare it to the original 15 from the manual testing. Another important thing about large-scale agile testing is that you're buying time by using people. Regardless of how good your automated test library is, the fact that you are producing more information faster means that you need more human brains to analyze it. And of course, you need to have a process to use them efficiently. There is a concept of cross-functional teams. It is a natural concept for humans. You go hunting in the morning, and then you're cooking it in the evening, and the responsibilities are shared by everyone. This process is present in any other area of the natural economy, which to a degree was a direct implementation of cross-functional teams several thousand years ago before it appeared as a concept in agile software development. But it's not how industry or large-scale research work in practice. In order to have information flow relevant for large-scale agile development, you need to have a process that is capable of generating enough information to fuel software development. And it cannot go without specialization when you talk about large-scale implementation. Software testing for large-scale agile development is built on 3 pillars. You throw platforms to buy time, you throw people to buy time, and you also look into the process. The process that helps you understand the system that you're trying to develop and make relevant decisions faster because some software testing cannot provide information faster. We teach a lot of software testers. We have several hundred of them who are working on Exactpro projects. We have many courses available on this very channel. By the way, like, share, and subscribe. But what is the main thing that we're trying to teach? Often, there is a mantra that quality is everyone's responsibility. And everyone means all software developers and all software testers. Quality is the firm's leadership responsibility that cannot be delegated or outsourced. The senior managers and executives within the company should be responsible for quality to fulfill their regulatory duties. The leadership can allocate resources by hardware, hire and fire software developers, but the main responsibility of a leader is to obtain and process information. The management is responsible for enabling channels that will provide them with information from several sources that they can critically assess before making decisions. The worst leadership failures come from inability to perform this core duty. On the other hand, software testers also have responsibility. The responsibility for the quality of their own work. When we teach software testers, we use 2 very interesting books in this area. One is Extreme Ownership and another one is The Scout Mindset. There are no bad teams. There are only bad managers. And we teach software testers that they are responsible for everything related to their work, as well as responsible for finding defects. If you are not able to do it, then there is something wrong with what you do and with the software testing process as a whole. The scout mindset is the motivation to see things as they are not as you wish them to be. Software testers also need to have this attitude uncovering the things that decrease the value of the software. Defects are valuable information, and information is the most valuable commodity right now. But instead of following the scout mindset, people for some reason are trying to cut corners, which usually results in the software that contains more defects. Testing is measured by accuracy, relevance, interpretability, and accessibility. In large-scale financial market infrastructures and mission-critical systems, sensitivity is more important than accuracy or precision. In Agile context, the main thing is relevance of information. And if you want to get good software testers, you teach them that there is no one else to blame for software defects leaked into production apart from themselves. Otherwise, there will always be a way not to take responsibility. Software testers are responsible for the quality of their work and for ability to identify defects. Software testing is important. In conclusion, let me reiterate the main ideas. Development and testing are two parallel processes with anti-parallel flow of information. Unit tests and continuous integration, continuous delivery, is software. Test-driven development, behavior-driven development, agile testing is software development. Software testing is an information service. Software development benefits a lot from additional information. Agility is responsiveness to change. Qualities is the firm's management responsibility, and it can be outsourced or delegated. Software testers, on the other hand, have extremely responsibility for the quality of their own work of finding defects and providing accurate, relevant information that can be interpreted and accessed by others. Large-scale Agile requires investment in software testing. To increase the pace of development without sacrificing the quality and resilience of the product, one has to invest more into hardware and people. One also has to have a coherent process in place to optimize the feedback loop. In essence, you have to buy time and flexibility with additional effort and additional hardware. This is the way to achieve responsiveness to change in large-scale mission-critical infrastructures. Please check Exactpro website to get familiar with a set of case studies related to large-scale Agile implementations and large-scale testing in major post-trade infrastructures for DLT network. Contact us if you would like to learn more about our services. And that's all for today. Thanks a lot for watching this video. Please help us to promote it by sharing it on social media. Feel free to like it and subscribe to our channel to get more relevant content on software testing, artificial intelligence, and advanced technology platforms. Let us know your thoughts in the comments below. And see you soon on our channel.